Good afternoon. We're going to be taking notes on 8.5 and 8.6 because we're going to learn the trigonometric ratios, tangent, sine, and cosine, and they're easier to learn when you learn them all together. So first thing we're going to do is do some triangle physiology. We need to know directional terms. Now, one of the things you're going to see is a circle with a line through it, sometimes with a degree symbol. That is the Greek symbol theta, and it's used to designate the angle that we're referring to. Along a similar vein, if there's a circle with a line through it, it might have a degree symbol. That is a phi, which is a different type of angle indicator. Okay, so for triangle physiology, first thing you need to know is what is considered the opposite side. So it's the side that's not adjacent to the angle. It is across from the angle, and it is not touching the angle. It's also not one of the angle's sides. So looking at this drawing, if we go from angle theta, the opposite side is the leg across from theta. Now, the second physiology term that we need to learn is the adjacent side. The adjacent side is a side that is touching the angle. It's next to the angle, and it makes up one of its sides. So on theta, the adjacent side is directly to the left. Now you'll notice that neither the opposite nor the adjacent side is the hypotenuse. That's because the hypotenuse never moves. It stays where it's at. It's across from the 90 degrees. So that's our third body part, is the hypotenuse. The hypotenuse is always the longest side in the triangle. It never changes position, and it's always across from the 90 degrees. Okay, so let's learn the tangent ratio. So the tangent ratio is part of trigonometry. Trigonometry is Greek for triangle measurement. And tangent relates the sides of the triangle to the angle. Pythagorean theorem relates the sides of a right triangle but doesn't say anything about the angles. Trig functions do. So a trigonometric ratio, first of all, it only applies to right triangles. Cannot use them with other types of triangles. Now, we already know two special types of right triangles. We know 45, 45, 90 triangles, and we know 30, 60, 90 triangles. And those both will work with trigonometric ratios, but also it can apply to more specific angle measures. Okay, so looking at our drawing, the tangent ratio is the ratio of the opposite side to the adjacent side of the triangle. So looking at our picture, if we're sitting on theta, the tangent is the ratio of the opposite side over the adjacent side. This again is true for all types of triangles, all types of right triangles, but not triangles that are not right triangles. Okay, flipping the page. All right, continuing on for tangent. The tangent ratio can be abbreviated TAN and then theta, tan of theta. Again, tangent of theta is equal to the opposite side of the triangle over the adjacent side. Now in this triangle, here's our theta. Our opposite side is BC, and then our adjacent side is AC. It can't be this one because this side is opposite the 90, and that's the hypotenuse. Now, what we're going to be doing is doing some angle solving, and you need to know what an arctangent is. Arctangent can be written ARC, arctan, or tangent with a -1 before the angle. And it is the symbol for removing the tangent from the angle so that we can solve for the angle. The tangent ratio is going to be used to find the angle of a triangle from two of its sides. So looking at this question, it says if tangent of theta equals 1/2, and that makes sense because opposite over adjacent would be 10 for the opposite over 20 for the adjacent, and that reduces to 1/2. So that's where that came from. So if we need to find the angle, what we're going to do is arctangent the entire left. So arctangent tangent theta equals, and then we have to arctangent the entire right. It must be the entire left and the entire right, or it does not work. When you arctangent a tangent, the angle comes out, and I have theta equals arctangent of 1/2. If they want an exact angle measure, that would be your exact angle measure. It wouldn't go any further. But if you put this into a calculator, you end up with 26.6 degrees. On your calculator, if you're looking for your arctangent button, it's almost always on the tangent button. So if I look at this calculator, here is my tangent button right here, and then as you can see above it in blue is the arctangent. So to get the arctangent, I would have to put second and then tangent, and now I've got my arctangent coming up on my calculator. And then it's 1/2, so 1 divide 2, and then a really good habit to get into is closing that parentheses before you push equal. And that gives us what we need. Now, I just got a really weird angle. It's like 0.46 something something. You need to make sure your calculator is in degrees. In mine, I push mode, I toggle down, and then I highlight degrees and push enter. So now when I put my arctangent in of 1/2, I'm going to get a degree measure, which is 26.6. So if you get a really, really small angle measure, check your mode. You might be in radians. Okay, so let's do some practice. Find the ratio of tangent theta. Okay, so tangent of theta equals opposite, which is 5, over adjacent, which is 7. So 5 over 7. Okay, on number 2, tangent of theta equals opposite, which is 9, over adjacent, which is 16. Okay, number 3. Tangent of theta equals opposite, which is 5, over adjacent, which is 4. And then the last one, tangent of theta equals opposite, which is 3, over adjacent leg, which is 7. So when they're asking you for tangent theta, they are looking for that ratio. Okay, so if we were doing this live, I would have you practice and then go over. So go ahead and pause the video and see if you can answer these correctly, and then check your answer. Number 5, tangent of theta equals opposite, which is 23, over adjacent, which is 57. Number 6, tangent of theta equals opposite, which is 17, over adjacent, which is 11. Okay, on number 7, something interesting happens. Tangent of theta equals opposite, which is 12, over adjacent, which is 8. Now, 12 and 8 reduce, so we need to reduce the fractions, and they reduce to 3/2. So your answer would be 3/2, not 12/8. Same thing happens on number 8. Tangent of theta equals 14 over 12. The opposite is 14, adjacent is 12, and that reduces to 7 over 6. So always reduce your ratios. All right, now we're going to do a practice that combines all of the skills that we've been learning. So given triangle ABC, find tangent of A. So tangent, this is A, so opposite is 2 over the adjacent leg, which is 7. Okay, number 2, find tangent of B. Here's B. Opposite of B is 7. Adjacent from B is 2. Notice these are different because we're referring them from different angles. All right, number 3, find the measure of angle A. So we're going to use this relationship to find the measure of A. So tangent of A equals 2/7. Now we're going to arctangent both sides. So arctangent tangent A equals arctangent 2/7. The arctangent cancels the tangent out, and I've got the measure of angle A is arctangent of 2/7, and I put that into my calculator, and I end up with 15.9 degrees. Okay, so let's do B now. I'm going to use this relationship here. Tangent of B equals 7/2. So I'm going to arctangent both sides. So arctangent tangent B equals the arctangent of 7/2. Arctangent cancels out tangent. Angle B is the arctangent of 7/2. We put that through our calculator and we get 74.1 degrees. So if they're looking for what it's equal to, the ratio, you do the fraction. If they want the angle, you have to solve for it. All right, flip the page. And we're going to skip the last page of this to shorten the notes up a little bit. So let's go on to the sine and cosine page. This is 8.6. We're going to learn the other two trigonometric functions. All right. So sine and cosine. The tangent ratio of a right triangle is one we just learned. It is the opposite side over the adjacent side. And in this triangle, if I'm looking from theta, my opposite side is AC. My adjacent side is CB. And again, the hypotenuse never moves. So the hypotenuse can never be opposite or adjacent. It's just the hypotenuse. All right, let's do the other two. So sine of theta is the opposite side over the hypotenuse. So the opposite side is AC. My hypotenuse is AB. All right, now cosine. Cosine is the ratio of the adjacent side over the hypotenuse. So in this picture, the adjacent side is CB. The hypotenuse is AB. Now, to keep these straight, there's a nice little saying, SOHCAHTOA. The first letter tells you the trig function. The second two tell you the ratio. So for SOH, for so, S stands for sine of theta. And then OH means opposite side over hypotenuse. So SOH, sine equals opposite over hypotenuse. CAH, the C stands for cosine of theta, which is the adjacent side over the hypotenuse. And then TOA, the T stands for tangent of theta, which is the opposite side over the adjacent side. So SOHCAHTOA, if you can just keep saying that and writing that, will tell you what your rules are. All right, let's do an example. Let's say that angle A is 30 degrees, and then I've got my side lengths. So sine of 30, remember SOH is opposite over hypotenuse. So opposite the 30 is a 1, and the hypotenuse is a 2, so that equals 1/2. All right, now cosine. Cosine of 30 is the adjacent side over the hypotenuse. So your adjacent side is radical 3 over your hypotenuse, which is 2. Okay, now the third one, tangent, TOA, is opposite over adjacent. So my opposite side is 1, my adjacent side is radical 3. So 1 over radical 3, which you will need to rationalize into radical 3 over 3, which is the other form that one takes. All right, flip the page. All right, example 2. Find the values of x and y to the nearest integer. So let's start with x. If I use angle 28, then x is my opposite side, and 1,000 is my hypotenuse. Now, if you think of SOHCAHTOA, the one that has opposite and hypotenuse is SO, or sine. So we're going to do sine of 28 degrees equals opposite, which is x, over hypotenuse, which is 1,000. So to solve for x, I need to get rid of the 1,000. So multiply by the reciprocal, which is 1,000 over 1. So we get x equals 1,000 sine of 28 degrees. When you put this into your calculator, we end up with 469.5. And that is rounded. If you're going to use your answer, so if you're going to use this for something, you want to go at least 6 places in your decimal, or your answer might come out inaccurate. All right, so now let's do cosine. So I want to find y. Y is adjacent, and don't use the rounded x, use the perfect 1,000. So adjacent and hypotenuse is cosine. So I'm going to do cosine of 28 degrees equals adjacent, which is y, over hypotenuse, which is 1,000. So there's your equation. And just like the first one, we need to get rid of the 1,000. So we're going to multiply by the reciprocal, 1,000 over 1. So the thousands cancel out, and I get y equals 1,000 cosine of 28 degrees. All right, running that through a calculator, I get y is 882.9 as my side length. All right, let's do example 3. Find x correct to the nearest degree. Okay, so nearest degree. So in the picture, 18 is opposite and 30 is the hypotenuse. So opposite and hypotenuse is sine. So we're going to do sine of x equals opposite, which is 18, over hypotenuse, which is 30. Now I'm not going to worry about reducing that because when I calculate it, it's going to come out the same. But to get the x out of sine, we need to arc sine x, and on the right, we need to arc sine 18 over 30. The arc sine cancels out the sine, and I get x equals arc sine of 18 over 30. And you'd put that through your calculator, and the measure of angle x ends up being, to the nearest degree, 37 degrees. And that would be your answer. All right, last one we're going to do, we're actually going to skip number 5. This is an isosceles triangle. And what we're going to do is we need to find the angles of the triangle, but in its current form, we can't do it because it's not a right triangle. So what we need to do is create a right triangle. So I'm going to drop an altitude straight down from A. We know that the altitude from the apex angle of an isosceles triangle bisects the opposite side. So this is 2, that is 2. Because it's an altitude, it's perpendicular. We also know that it bisects the top angle. So this one and this one are actually the same angle. What this gives us is a nice right triangle that we can use. So this is the right triangle that we can use to find the angles. All right, so let's start with angle B. I have 2, which is adjacent, and I have 5, which is the hypotenuse. SOHCAHTOA, adjacent and hypotenuse is cosine. So I'm going to do cosine of b equals 2 over 5. That's my beginning equation. Then we're going to arc cosine of b, which means on the right we're going to arc cosine 2/5. The cosines cancel out, and angle B equals arc cosine of 2/5. Running that through a calculator, we get the measure of angle B to be 66 degrees. Now, since this is isosceles and the two sides are the same, B and C are also the same. Base angles are congruent, so the measure of angle C is also 66 degrees. So we got 2 for 1. All right, so now we're going to find A, but in our right triangle, we're only using half of A. So I'm just going to call it X. So from that position, my opposite side is 2, and then 5 is my hypotenuse. So opposite and hypotenuse is sine. So sine of x equals opposite, which is 2, over hypotenuse, which is 5. And there's our equation. So now we're going to arc sine x. And that means we have to arc sine the entire right side, which is 2 divided by 5. Arc sine cancels out the sine, and x equals arc sine of 2/5. Okay, inputting that into the calculator, we get x equals 23.57 with a whole lot of decimals. X was half of angle A, so I'm going to multiply by 2, and that's where I get the measure of angle A is 47 degrees. So I had to get the angle and multiply by 2. All right, so remember, SOHCAHTOA, you should write that on absolutely everything, and you definitely need your scientific calculator for the homework. Try to get really good at one calculator and use the same one through the end of the unit so you don't get stuck on a test with a calculator you can't use. Have a good afternoon.